They said your DIY wheel alignment is inaccurate without the $20,000 machine. Is it true? Hello, my friend. Welcome to Professor's Garage. Is wheel alignment something you want to do in your garage? But everyone is saying it can only be done accurately in the shop with expensive equipment. Today I'm wearing my professor's hat. I will not only delve into the essential steps using basic tools, but also reveal the ultimate truth about the accuracy of DIY alignment. And the truth may surprise you. So let's get right into it. First, let me explain what wheel alignment is about and visualize the setup to get it done in a home garage. Alignment involves three key dimensions we need to keep an eye on. Toe. Think of this as the direction your tire points when viewed from above. This is straight, this is toe in, this is toe out. Camber. It's the wheel's angle relative to the vertical axis. Caster. Caster is essentially the angle of the steering pivot. Now, I don't really care about caster, which doesn't affect tires. Camber is relatively easy to check if you have the right tool. Toe is very important, but the most challenging to check unless you have access to a $20,000 alignment machine. For those of you with the garage like the professors, can we do an alignment check with basic tools like these? Let's visualize it and do the math together. Okay, let's do some math together and focus on toe alignment. So with this exercise, what I would like to do is to show you the setup, but also show you where to focus on in order to get really accurate measurement. So again, imagine if you have a toe in like this. Obviously, I'm exaggerating because I want to show you the angle. So with this toe in, you want to measure the angle between the direction of the wheel and the body of your car, right? The wheelbase. Side A is the direction of your wheel. And then C is the reference line parallel to the side of your front and rear wheels. And between A and C, there's a toe-in angle, right? So how can you do that calculation? If you can establish the reference line, the green line C, then you can draw a line perpendicular, right, to the wheel and measure the difference, which is B. And you can calculate the tangent by B divided by A, which is going to be the tangent, and from tangent you can Google arctangent to find out what the toe-in angle is. So this is the basic math to do the toe measurement. Now, a very important part of this measurement is to establish the reference line, the green line here, the C line. So how can we do that? Again, this is the arrangement of the three sides. In order to establish the green line, which is going to be parallel to your wheelbase from rear to front, right? What you are going to do is to measure the same distance from the center of the rear wheel as the distance from the front. So the same measurement from the front wheel and from the rear wheel to the reference line. If you can do that, then you can establish that reference line. Of course, when you do the actual measurement, there is going to be error in the measurement. But because the wheelbase from the rear to the front is going to be quite long, actually, for Honda Odyssey here, it's about 3,000 millimeters or 3 meters long. C side is 3 meters long, and given Honda's whole spec of 0 to 0.16 degrees, according to my computation, you will have to make a measurement error of 8.4 millimeters, which is quite significant. And it's unlikely you are going to make that big of an error in the measurement. There is room for error. So this part, I think, is the easy part to establish the reference line, side C. Now let's go to the difficult part. Once you establish the reference line, the green line here, we're going to do the actual toe alignment check. What you are going to do is obviously measure the distance from the rear edge of the wheel to the reference line. And let's say the distance is R. And you're going to do the same from the front edge to the reference line. And that's referred to it as F. And so obviously if you have a toe in, F is going to be greater than R. And that difference is this that I'm drawing. This is actually B, the difference between F and R. If B is positive, you are going to have a toe in. If B is negative, it's toe out. And this white line that I show you here, the white line is A, which is easy because this side A is actually the size of your wheel. And we can do the calculation. A is the wheel size, and then B is F minus R, the difference between the front and the rear. And then you can compute the tangent, right, of the angle based on B divided by A, the difference divided by the wheel size. Again, going back to the Honda specification for this Odyssey, let's say you have a 16-inch wheel, which is about 406 millimeters, and Honda spec is 0.16 degree toe in. So with that, the difference, which is B, should be within 1.1 millimeter, according to my computation. How can we make sure we have accurate measurement within this specification? And I'm going to show you the procedure. So let's go back to the garage, and I'm going to show you exactly how you can make sure and be confident about the result that you get from this toe alignment. Okay, so let's go back. We'll use this Honda Odyssey as an example. It has been displaying a slight pull to the left. This vehicle pulls to the left, so I have to steer to the right a little bit, suggesting a potential misalignment on the toe. Here are the alignment specifications we are working with. For camber measurement, use a camber gauge like this. Make sure you park your car on level ground, like in your garage. Confirm the steering wheel is straight and center. Double check the vehicle sits evenly from right to left. Make sure all tires are correctly inflated to the recommended PSIs. Place the camber gauge against the vertical surface like a wall or a door and adjust the reading to 0. Position the camber gauge on the wheel at the center of the rim or on the brake rotor. Now let's dive into toe alignment. Pick a side, say the driver's side. Project the laser from the rear to the front. Ideally, the laser should be parallel to the wheelbase from the rear to the front wheel. What we are going to do now is to measure the distance from the center of the front wheel to the laser line, and hopefully the same distance from the center of the rear to the laser line. So this is the distance from the rear wheel to the laser. And for now, this is the reading of the distance from the front wheel to the laser. So they are different, and you want to adjust the laser so that the distances from the front and from the rear will be the same. This is going to take some time, so be really patient. I have double-checked the measurement for the front and the rear. Also with the caliper measuring tool, the laser line is parallel to the wheelbase. Even if there is a 1 millimeter error or difference, it's not going to be a problem because of the long wheelbase. At this point, the reference line should be good enough. Now that we have established the reference line with the laser, it's time for the most exciting part, toe alignment check. This is the driver's side front. Grab the caliper measuring tool, which is accurate to 0.3 millimeters. We're going to measure the distance from the rear edge of the rim to the reference line. And now, once you get the measurement, zero it, because we're interested in the difference between the rear edge and the front edge. Now let's go to the front edge. According to the spec, because it should be a toe in, and so I'm expecting a positive number, but it's actually negative. That means the front is actually toeing out a little bit. But we are going to take this measurement, and we are not going to just take one measurement only. We're going to do 20 measurements and then calculate statistically how accurate our readings are. So we are going to continue this process. Now that we have done our measurements, let's do some data analysis to see how accurate they are and how much confidence we can have in the alignment measurement meeting specifications. So you can ignore the code here, but I'm going to give you the results and my interpretations. Okay, so the values that you see here are the actual measurements that I took. And these are negative values because it's actually toe out on my left front wheel. And so let's run it, and I'm going to show you my result in a second. Okay, so if you run it, and you will get the mean, which is the average of all these values, minus 0.24 in millimeters. That is the toe out. And then the standard deviation is 0.11 millimeters. Now, this may make no sense to you, and let me run this distribution, and I'm going to interpret the distribution for you to show you the confidence level that we can have in the data. Okay, so once we run it, this is the plot. And what it shows is that on a normal distribution, and I assume the values here should follow a normal distribution. And so this bell curve is the normal distribution. The red dots are the actual values that I have taken. On this distribution, we can obviously identify the mean. The mean is roughly here, okay? And mean minus 2 standard deviations, 0.24 minus 2 times 0.11, about minus 0.46, I believe, right? That is the 2 standard deviations below the mean. And then you can also calculate 2 standard deviations above the mean, which is around 0. You can do the computation. So between minus 0.46 and minus 0.02 actually, that is the 95% confidence interval. What does this mean? It means that it is very likely with 95% probability that the actual value should be within this range. Another way to say is it's very unlikely that the actual toe reading is outside this range. So with this, you should be confident that your reading is within this range. And if you think about this, the specification for Honda, in this case the Odyssey, is within 0 to 0.16 degrees toe in, which converts to 0 to 1.1 millimeter, right, in our measurement. So as long as you can get within this range, you should be good. Our range here within the 95% confidence interval is much smaller than that. It's less than half of that. So with this, I'm confident that when you do this alignment using the procedure that I have shown you, by taking multiple measurements, such as 12 measurements here, you should be able to achieve the level of accuracy good enough to meet the specification. That is the major conclusion from this experiment. Here are the final readings of camber and toe on my vehicle. Look at the toe numbers of my front wheels. It's no wonder it pulls to the left. This DIY alignment check, my friend, is accurate enough to ensure your vehicle falls within acceptable specifications. I have done the analysis so you don't have to. But make sure to follow the procedure with the tools shown in this video. You know I will need to adjust and correct the alignment of this Honda Odyssey, so stay tuned for a future video on that. I trust this video has provided you with insights and clarity. If it did, consider extending a like and subscribing to Professor's Garage. Remember, if a professor can do it, you can do it. Until next time, may the Lord bless you and grant you peace. 平安。